hope it is. But will we do it perfectly?
No one's perfect.
Thank you.
With such enthusiasm, yeah.
Are we ready?
Yes.
Some of you have bronte bread, the rest of you just hang in there, your nutrition is coming. Section 1.4, let's finish it off. F of x. In algebra 1. If I taught you, which was only, what did we figure out? 3 of you? 3 of you. This is our F of cow section. There was a cute little cow, but maybe you were sleeping that day. It's our F of cow section. It was one of the most confusing things in algebra 1 besides, I believe, factoring. Factoring is a beast. So, I have little boxes here instead of little cows, even though the cows are way cuter, to prove a point. Have I been trying to impress upon you the fact that x's are not always x's?
Yes.
What?
Because x's usually in algebra just stand for independent variables, right?
Yes.
Okay, so what other types of independent variables could we have?
T.
T's, that's a very common one.
Z.
H's, because we had that yesterday with volume, but we also had R, right? Long story short, can the independent variable change?
Yes.
So thus can the dependent variable change?
Yes.
Okay. So if that's true, even if you're given f of that's awkward. Okay. Even if you're given f of x is equal to x squared minus 4x plus 7, do you realize that x is really just marking the spot for the input? Whatever the input is. So if x can change to t, for instance, let's jump to the easy one because he's the easy one. How would this equation change?
F of T.
It'd just be, yeah, it's an easy one. It'd be
F of T
bless you.
T
T
squared
squared minus
4T
4t plus 7.
What is smart kid
Yeah. Because our directions are just to find f of t, and if we're given f of x, it's like, well, sweet, all we have to do is change the t's. Sweet. And there's no simplifying because, as I've been teaching in my algebra 1, when you're multiplying like bases, you add the exponents. If you're raising power to a power, you multiply the exponents. If you're dividing like bases, you subtract the exponents. But what if you're adding or subtracting expressions?
You do the x thing.
You're thinking factoring. Sorry, you're thinking like an algebra 2 kid, which is great because you have way more training than the algebra 1 kid. Long story short, can I simplify this any further?
No.
Not unless I'm rewriting it with factoring. You're right, but we're not doing that. I can't combine these two or all 3 of these because what is true about each of these terms? They're all different. No like terms, so we're done, right? So what's going on if we're trying to answer letter A? If we have this function, we have this model where it's like, hey, put the input, simplify, you get the output.
13.
How? I'm just going to say that he's right. We'll see. Plug in -1. So the new input is -1. So who's being squared?
Wait,
-1.
12,
Who's
my
being
bad.
multiplied by -4?
12.
-1. Then 7, well, it's just plus 7.
It's 12, not 13.
How come? Because that's 11, and 11 plus 1 is, so he was close. But,
Yeah, I'm just a little slow.
or you were really fast and just made a little mistake. Either way.
I hit on that.
So you guys agree now?
Yes.
But then he fixed it before they even came up with it. Well. So I wasn't super worried about you guys being able to do this without needing me. Or even, to be honest, doing this, although a few of you would have made some negative, positive, I don't know, adding mistake, let's be honest. But if you take it slow and careful, I think most of you could have done this one. I'm more worried about you guys rocking that one. Ready, set, in your groups, you can even collaborate. Go. Plug in the input. To be honest, I think some mistakes might happen. So let's see. Plug in and simplify. Plug in and simplify. Then we'll go up and fill in those blanks we left above. Prove me wrong.
It's just x plus 1.
X plus 1 squared.
Prove me wrong. Get it right.
Well,
But you have your group. Wrong group.
So you have the FOIL, so it's x squared.
I don't think we let me get it.
Squared minus 2x. Although you can check me on that, because
This is what I got.
squared plus 2x plus 1.
Oh, okay, I gotcha.
So you have to FOIL it, and it ends up being x squared plus 2x plus 1 minus 4x.
If someone has an answer, they should be holding their notebook and ready to show you, but not showing you right away. You're supposed to try it for yourself. But if anyone's holding their notebook, they're ready to check their answer, just so you guys can catch up.
Yeah, we got it. Yeah, we got it. You get it?
Bro, that's what I got.
When you FOIL it, or like
Part of it's right. Part of it's right. So I want you to stay and see how it's right. Then you can go.
Because 1x plus 1x.
You guys are collaborating this one, right? It's not right though.
Can you check my
You don't have to factor when you're done. You can do like letter B and just leave it as a polynomial, but I haven't seen a right answer. Or maybe I've seen it just
Oh, wait, I did this wrong.
Hey, so it's like this.
Wait, can you check my Oh.
Whoops.
This is the answer.
Oh, I didn't know. I'm not giving out answers. I'm just asking if a whole group is. I'm not giving out
No,
answers.
that's
Oh, that's what the whole group
Yeah.
is.
No, that's all I got.
Oh. Get the whole group on board. People can sometimes make the same mistake. I'm banking on most of the class making at least one similar mistake.
Okay, I got this.
No.
got it.
I can do negative 2 minus 4 negative 2. Yo, I'm retarded.
I'm just kidding.
Oh my god.
So far, so good?
Yes.
We got it. 4 times 1.
No, you just do the 4, not the 9.
Yeah, but it's called.
When you distribute, you have to distribute the negative.
So I was right. I'm out here, guys. Yo, what's
So it's the last answer.
4. 1 minus 4 is 3 plus 7.
Where?
Right, negative 3 plus 7. Guys are killing puppies.
No, see, that's what you were trying to do.
Yeah.
Oh, we did not even do a square.
We got it. You got it. You got it. We got it.
Oh, we got it.
It smashes into the wall.
And the wheels are big.
We're ready.
How did the puppy die? Some of you can't read it, but at least you see a cute puppy. Asking not to die. Here's one way a puppy could die. I saw multiple puppies murdered around the room. Is
Not kill my dog.
that
Copper, but
true?
Bro, we didn't even do that. We did
Anytime you do this, a puppy dies. I mean, puppies are gonna probably die anyway somewhere in the world. But still, don't be the cause. But even the hypothetical puppy died. What is the correct way to go about? Is that what we're doing?
Yeah.
Emma, go for it.
Okay, so you have to FOIL it because you have to separate the two equations. I know. You were the one that told me.
Who's telling you something else?
Someone else is gonna stop.
So what should it be?
x squared plus 6x.
X squared plus 6x plus 9?
Yeah.
Okay, as long as it's not any of my devices. Now, hold on, pause. When I taught Algebra 1, to be honest, we were playing catch up a lot of the semester, and I had broken my foot, so we were just doing what we had to. However, library stairs, they're a killer. There is a shortcut to getting this. There is a shortcut. But couldn't you technically have just FOILed and done x squared plus 3x plus 3x plus 9?
Yeah.
And then combine like terms?
Yeah.
Okay. But for those of of you that do know the shortcut, there is a shortcut, but this is not it. Squares do not just distribute. Like, yay, let's go across pluses and minuses. That's awful. Yes, for those of you that can see this, what else does not distribute across addition and subtraction? Radicals. Yes. It's okay. What is the shortcut, though? There is one. And if you like shortcuts, there is a legal one, but that is not it. What's the shortcut? Okay, doing this in your head. I mean, square the first. So what is x squared?
X squared.
Square the last. What is 3 times 3? And then double, which means 2 times. Double the outer times, well, I
Unless
should do
it's
that.
subtraction.
Double the first times the second. First times the last. When you foil, you're always going to, I should say a perfect square binomial. When you foil, you will get the squared of the first. You will get the squared of the last. And you're going to get double the first times the last. So there is a quick shortcut. But to be honest, it's not near as quick as, like, I don't know, this one. That's a lot nicer of a shortcut, right? Difference of squares, a squared minus b squared, awesome, that's cool. You could write it out, a squared minus ab plus ab, cancel, minus b squared. Like, you could write that one out, but there is a nice shortcut. This one's just not as nice. I mean, it's not super simple. But you could square the first, square the last, double the first times the last. It's there, it's a shortcut, but if you just made that mistake, can you just write it out and foil it? Is that cool? Because otherwise you're going to keep on killing puppies. Even the kids that know not to kill puppies end up accidentally killing puppies at some point during the fire. So, are we trying to avoid this mistake?
Yes.
Yes, which is why I say it's the puppy rule. Okay, let me back. So I was a little worried that some of you wouldn't know how to plug in x plus 1 properly. But as I walked around, I think most of you, it's okay, just case over. It was way more dramatic if I just pushed it off to the side. Especially if you guys thought it was going to crash into the wall. Orientation might be what? Not bad. But let's assume you didn't make that mistake. Let's assume you foiled it like you were supposed to. And you got what to be the proper simplification of this?
X squared plus 2x plus 1.
And let's assume you also didn't kill, here, you're welcome, a steal, meaning you have a minus 4x and a minus 4, not a plus 4, because you realized this was plus a negative 4, and the negative had to go to both, not just the 4. If you didn't have a minus here, 4 will seal. He's so cute too. And then plus 7. If you avoided that mistake, and if you avoided this mistake and got the minus also, hopefully you were able to properly combine like terms and get your final solution to be x squared minus 2x plus 4. Some of you might have gone on to try to factor. That one would not have been fun. This one would not have been fun either. But it was okay just to stop with the polynomial. Good question. Why did we even have to square? And why did we even have to distribute the negative 4? Because any time we have an f of a function notation, whatever comes after this name of the function, ooh, isn't there something we have not filled in yet? Way up here somewhere? The name of the function, whenever we're looking at f of x, whatever that input is, this little guy on the outside is just the name. It could be f, it could be g, it could be h, it could be, yesterday, didn't I have a v of r and a v of h? I think I wrote that down.
Yeah.
Maybe I just wrote p. But this outer guy, it's just the name. It's not even a variable. It's not x, it's not y, it's just a name. The inside, this, whatever is inside the parenthesis, that's the input. which, yes, is usually blessings, and x. However, it could be a t, or it could be some nasty expression like x plus 1 that needs to be lumped together, substituted in the input file, and then dealt with legally, accordingly, properly, in order to be able to find the proper solution. Now, here's a dealio. For some of you guys, to be honest, it's super easy. You didn't need me to explain any of that. And you were like, oh yeah, x squared minus 2x plus 4. I had that like half an hour ago. Hyperbole. But for some of you, to be honest, even this first step was hard. And that's okay. It is what it is. For some of you, your brains click like this. You remember it from Algebra 1. So even Algebra 2 was boring, and now in Precalc, you're like, great, we're doing it again. But to be honest, I can almost guarantee that a third of you, if not a half of you, made a mistake somewhere. And for some of you, it was the very beginning. So what do I need you to do in groups whenever we're collaborating, especially with homework questions on Monday? Check, but check in a way that you're giving grace. Yeah, but help in a gracious way, in a loving way, in a, hey, I get it, people make mistakes, let's talk through it way, right? Because is it really easy for some kids that just math comes like this to be like, it's this answer, just get it. Like, you're fine. Why are you, I don't understand. Like, to breeze past it and just kind of treat someone else like they're dumb because they don't get it. It's not even your fault if you've ever accidentally done that. So I need you guys to slow down, some of you who are like, yeah, got it, good. Because this class, as much of it as it is about you, it's not about you. It's about all of you, right?
Yeah.
Okay. And some of you, to be honest, you're like, I should be in honors. Well, it doesn't matter. You're in here. And we're all going to learn together. But can we at least realize that whenever we're doing group work, don't come into it with the assumption of, man, guys, that was easy. And here's the poor kid who's like, huh? So ask questions, look at work, and if you see a mistake, like, oh, no big deal, time out, let's talk about this, and try to show them why it is what it is. Are we cool? Yeah. Thank you. I'm just saying that because right here is a key place to say time out. I've seen so many mistakes over the years in regular and honors and calculus classes of kids messing this up. And if you really want to be tested as to whether or not you can do that, some of you might have seen something like this last night.
Nah.
Yeah. Well, you have to start. But anyway, coming back. This tests whether or not you really know what you're doing. But before this, the craziness, we're going to talk about this. Piecewise functions. Oh, you all started writing it. People who use pen, it happens. I confuse you. I'm sorry. People that use pencils, no big deal. Erase. Here we go. Piecewise functions. I think this even is what comes up next in your homework before the difference quotient stuff. The difference quotient is kind of what I would naturally want to do right away, but we'll do this page first. It comes up first. What if you are doing f of x and you have to plug in things and all of a sudden you have a piecewise function? You've seen it before. It came up in Algebra 2. Maybe a couple. A piecewise function is merely just a function that's defined in pieces.
What is this that like matrix thing?
No. I get what you're saying, but no. You're thinking system of equations, and you have to put it in a matrix, and substitution, elimination.
It's because I was that like weird line on the side.
This one, right? The brace. This thing is just used in math, basically, to group stuff together. So last year you saw like XYZ with one of them because it was saying, hey, it all goes together. In piecewise function, it's basically saying we need all of this to define that. So one function defined in two separate pieces. Now, to be honest, some teachers would totally force you every single time to make a graph. And actually, Calculus had a homework due today where they had a piecewise function, and their book is kind of cool. Not only do they have CalcChat, they also have these little QR codes, and some of their homework problems are pink, and if you scan it, you can go watch a teacher teach the homework problem. It is helpful. Calculus is also hard, but helpful. But the teacher, in teaching the piecewise thing they were doing, started off with a graph. It's valid. I don't know if it's always necessary, but it's valid. So if we were talking about a graph, just so some of you have a visualization for what's going on, doesn't x equal 0 fall right here at the y-axis? Isn't that a thing? So when I I look over here, these inequalities, and this one says, hey, to the left of 0, to the left of the y-axis, this is happening. And to the right of 0, oh, by the way, including 0, this is happening. What's going on graphically without me reviewing all the graphs and how I can do it faster with the graphing calculator? Parabola shifted up then. I'm going to go ahead and show you what x squared plus 1 would look like to the left of, but not at or on the axis, hence we put a hold. Everywhere up to, but not including 0. And then x minus 1, aligned with an intercept at -1 and the positive slope of up 1 over 1. What that would look like. We could graph a piecewise function and get whatever's on the left of the separator is what I call that little number in the inequalities. And what's on the right. But to be honest, we haven't done a lot of graphing. We talked about that yesterday and kind of the day before. So maybe the graph isn't the point. Maybe the point is, would you know what to do and where to put the -1 if it was time to plug in, or the 0 if you were being asked to plug in, or the 1. Now remember, the notation. Does this in any way, shape, or form mean what a variable next to a parenthesis has meant all the time of all your math training up until now in function notation? Does it mean multiply? No. But a lot of kids think it's this. All of these mean function of input, not an f times a number. And that's where a lot of the mistakes come. Maybe an Algebra 1 teacher did not do such a great job, and for 3 of you it's me. Maybe an Algebra 1 teacher did not do such a great job of drilling it into your head. This is not f times, f times, f times. It's f of, function of. Input goes into f, whoever he is. Oh, there he is. This is an x, this is an x, this is an x, this is an input, input, input. Where? To the dude. Ah, but there are 2 different pieces, so which one? Both? No. Good guess.
Whichever one it applies.
Dylan, what do you mean whichever one it applies to? I totally agree.
-1 is lower than 0, so it goes on.
Because we're trying to figure out what is the f of x value when x equals -1. That's the notation for this. So who is this guy when x is, I can't put -1 in this piece. It's not legal. What piece is -1 proper in? All of these left of 0. So -1 goes in the top piece because of the inequality saying, hey, you belong with us. Come here. Dun, 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 dun. So where should 0 go? Nathaniel, what's that?
Bro, how's 2 less than 0?
It's not about the y being less than 0. It's about the x being less than 0. So we don't care about what comes out. What comes out is whatever comes naturally out. We only care about the input being what's legal. Think about a computer program.
I see that.
A computer program? Aren't there tasks when a computer is told, like, oh, hey, do this or input this, and it leads you, well, actually, my Google form, did you guys fill out the Let's Get the Year Going form?
Yeah.
Did you realize there was a question on the bottom of the first page, did you go to Heritage last year?
Yeah.
I sent you 2 different directions based on how you answered that question. If you did go to Heritage, I'm like, hey, skip this page, go over here. If you didn't come to Heritage, I'm like, hey, give me some info, that's cool. So depending on the input, you get sent different places, and that's like a computer program.
For real?
Yeah, or even video games, right? Because if you die, you're going to be given like the game over screen rather than like, oh, keep going. And that's in so many little tasks.
Yeah, but I never tried.
So what's legal? Input. Okay, cool. Oh, hey, where's the 0 going to go though?
The bottom one.
Because 4 equal to the bottom one includes 0, not the top. The bottom one includes 0, which is why it's filled in. Oh, you guys can't see it, can you? I apologize. My hole is like on top of the line, so you can't see. There, that's This one doesn't include 0. It has a hole at 0. This one does include 0, so it's nice and filled in. 0 minus 1? Negative 1. But the y could be whatever. It's just the 0 belonged in the second piece. And the 1 belongs in the second piece as well, because 1 is greater than 0. So 1 minus 1. You have to figure out where is it legal for the input to go. Oh, then go to that piece.
So if we get this on the homework, I haven't seen it that problem come up yet. We just do this.
Because I think they're just asking you to do like f of, and so they've given you a weird piecewise. Just put it where it's supposed to be. So this is actually going to show up. I think there's like, I don't know, 20-something problems, but I only give you like 2 or 3. So it's in this type of thing where you're plugging in, but you have a weird piecewise.
Will they all only be once or sometimes once?
Well, remember in, oh, there we go. In this one, they happen to give you like 2 that went in the bottom piece, and just keep it legal.
Will the 2 like other like let's say
Like the x plus 1 and the t and that sort of stuff.
yeah. Like will one ever fit into both equations?
If they give you a piecewise, they're probably not asking you these types of questions because it would change based on what you have.
Okay.
Does that make sense? They could ask you this, and you would just put t's and then be done. In that case, yeah, I guess you would have both. Okay. So now here's the weird one. That really tests if you were like, oh, that f of x plus 1 was easy. This might not be. This might not be. And if you were like, the f of x plus 1 was hard, it's okay. We're all going to struggle through this together. Difference quotient, super important formula for calculus. So to be honest, you're not going to really know what this thing is for. Because I'm not teaching you what it is. I'm not teaching you what it's used for. To be honest, Calc AB kids might not really know what it's used for yet. BC should. John, you recognize this guy.
Yeah.
But usually what's in front of this guy as age approaches? And what is it the definition of? Because it's a forever card that the Calc AP kids had memorized last year, he did Calc BC. It's like a basic, fundamental, super important thing. But the point for you today isn't to know what it is and what it's used for. It's just to know, hey, if you have a this guy and a this guy, how do you make him out of that? Literally. It's not using it for some grand, greater purpose, which it actually has. It's really just, this is Precalc or Algebra 2 skills. Could you make this special ratio using that function? It all has to do with function notation. And we're just asking you to develop the skill of being able to go from here to here. So, what I want you guys to see is that this whole thing, called the difference quotient, has, well, some key different pieces. I like color coding because I think it's helpful, so I'm going to go ahead, just because I only have 4 colors, and I'm going to use them. We're trying to figure out what is f of x plus h. We have to build that out of this using something like the f of x plus 1 skills we just did. Who is f of x? I need to put a minus and then put that next. Don't forget, this is one big old ratio, one big old fraction. And the cool thing is, I can just put it over h. The over h never changes. The f of x will always change, but they'll tell you what it is. Just don't forget to put it in parentheses, or else your negative will not distribute properly and your seals will die. Or my seals will die. Anyway, seals will die. We haven't talked about that. Today's big thing were the puppies, but not distributing negatives, well, that's a seal killing mistake. So who is f of x plus h? Who is f of x? Put it into this special formula, this special pattern. Simplify as much as possible, and you will have met the objective that we are asking of you in Precalc for the difference quotient. So, to find this guy, to make this guy from this given function, which the function will change, it is what it is. Don't worry, this is for at the close of class. Ivy, make sure to get your note from me. Who, or what, or how do I find f of x plus h? pretend like it's the problem we just did. With f of x plus 1. What would you guys do?
How are we supposed to know what h you plug in?
You don't need to know. Just leave h, plug in x plus h like you would plug in x plus 1. And simplify with x plus h like you would simplify with x plus 1.
Minus x plus h squared.
So you're going up here?
Yes.
Nice. You're saying, okay, there's a square, there's a minus 4, and there's a, hey, isn't this the same thing we just used?
Yeah.
Except instead of x plus
1.
1, now it's just x plus h. So hopefully you'll avoid the mistakes you made the first time, because we know what the squared actually means, and we know the negative 4 needs to distribute, right? But this time when we simplify, instead of being x squared plus 2x, what is it going to be now?
X squared plus h squared.
H squared is going to be down here.
hx
Plus 2.
2hx.
Now, here's the dealio. If you were to FOIL, you could have xh or you could have hx. I don't honestly care which one you put. As long as you realize xh and hx, if you FOIL, are the exact same thing because multiplication is commutative. So x times h times x, however you do it, they can combine. Just like a second ago, the 3x and the 3x were the same, or for ours, the 1x and the 1x were the same, we could combine. Ends up just being double. And for those of you that are like, oh, you did the shortcut, I know, I'm sorry. But couldn't you have written it x plus h times x plus h? You should have gotten here. Now hold on, we're not done yet though, because that's just this. Now what?
Minus 4x.
Okay.
Minus 4
Distribute negative 4.
plus 7.
Negative 4x minus 4h
Plus 7.
plus 7. Now this isn't going to simplify down to be as nice as the other one because we have h's in here and it kind of messes everything up. Meaning, are there any like terms?
No.
So we have to put that and that. Here we go. We're building the difference quotient, and the difference quotient needs f of x plus h. Whoever he is, no matter how messy, it needs f of x plus h first. I know, it's okay. Big sigh. Keep going. Some of you are freaking out. Just hold on. It's okay. What comes next? Minus, good. I put the minus in the fraction bar, because we need the minus and we need the fraction bar. What comes after the minus? And who's f of x? Yeah, so throw him in. We already have him. They gave it to us. And then what do we get to write in the bottom? Yeah. Okay, so that's the part that never changes. The minus, the over, and the h. That never changes. F of x plus h, we have to build f of x. Well, it's whatever's given. If you got there, great job. You built it. But now stuff can simplify. Do you see anything that can simplify? Okay, we see h's and h's, but careful, does everything have an h?
No.
Don't do him yet. But what can we add?
Combine
But what
them.
can we do?
Do like combine like term.
Can we distribute the negative? Because we're not going to kill a seal. Not today. Not on my watch. And then can we see, oh, hey, there's an x squared and a minus x squared.
Cross the middle.
They're going to cancel once we distribute the positive ones that don't change anything, so the parentheses are gone. This isn't multiplying. This is adding negative.
4x.
Hey, the 4x cancels too. The negative 4x. Oh, the 7s do too. What does everyone left have?
H. So then take out the h.
Yo, how did this 7 cross out?
The difference quotient is very special, has a very special way that it's formed, and a very special meaning. This happens basically every time. For any polynomial, I should say. Nathaniel, what's up?
How do the 7s cross out?
Oh, because it's a 7 and then the negative came over, so it was plus a negative 7. 7 minus 7. Yeah, I distributed my negative because it was minus. Lo siento. I didn't. I sometimes do, but yeah, you're right, I didn't. Yeah, I brought my negative in. That's a negative sign. I apologize. It was just a green, and then I brought my negative in. So my final, simplified as much as I can possibly do it.
2x plus h minus
Dun, 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 dun. And then John would say, sweet, so the derivative is 2x minus 4, but that's not for you guys. Actually, he would have said that way back there. We just finished section 1.4.
Yay.
The homework that theoretically was due today, but I extended yesterday at the very end of class if you were listening, and if not, I'm so sorry. So Monday. Yes, on Google Classroom, the deadline was updated as well. But technically, on our calendar, it was not just finish section 1.4. It was also, I have questions ready because I'm guessing what you might have questions on in homework. It doesn't mean not to do it. That means you can try. Just don't kill yourself and totally stress out if you don't totally understand it. You guys are killing me a little bit right now. Can I teach you something real fast about this class? Okay, on the calendar, technically, our goal is to finish 1.4 and start 1.5. I look at the clock and I'm like, there are 2 whole minutes left and 10 seconds. We would have totally changed the page and gotten this written down so that on Monday you guys could pop straight back into your 1.5 notes and take a couple of more pages of notes. But what's the struggle if you look around the room right now?
We all packed up.
Why?
Because we want to leave.
Because you... Well, no, let's talk about it. Why'd you all pack up? I didn't say we were done. Because we finished 1.4 and it's like, man, we've worked enough today. We're done. And then probably someone looked at the clock and they're like, it's close to 37. Most teachers in 2 minutes, who cares? In Precalc, 2 minutes are a big deal. Because, how long is it going to take you to write these notes on Monday?
Like 10 seconds.
Okay. When you guys come into class, does everyone come in at the exact same time, sit down at the exact same time?
No.
No. Aren't things on the board or warm-ups for you guys to be doing as you get in to kind of get ready for class?
Yeah.
Okay. So there's going to be someone who has this page of notes done, and they're just kind of sitting there twiddling their thumbs while the rest of you are still coming to class, right? Wouldn't it have been better if we had taken this quick little baby page of notes, had it totally done? You guys know we're going to section 1.5 on Monday. You already know the title to put into your table of contents. And these guys could be taking, I don't know, other pages of notes instead that actually have examples that you can solve. Now, why am I going through all of this explanation? My class procedures aren't done. Like, I have reasons to them. Does that make sense? So when, on a future day, now that you know my rationale as to why we wouldn't just be done and we would use those last 2 minutes in a way that would help us, not just today, but also on Monday, it's not because I'm being like super picky or OCD or anything else. It's just because there's a purpose, there's a method to my madness. Maybe it's not madness at all. Okay? So, next time we're going to pack up randomly even though I don't say, hey, guys, we're done?
No.
Most days we work till we're done. But, in class, I cover notes, I cover illustrations, I cover examples. Okay? Most days, though, we don't start. Did you guys do that in Algebra 2 a lot?
Yeah.
Sorry. But, the reason we're not starting homework is just because there's a lot to cover. I have your notes, come grab it. But otherwise, the rest of you guys, see you later. Happy nutrition. If you want that, come back with your dollar. I'd love to take it. Have a great weekend, guys.